Okay, so I think we can start now. So the topic seems very threatening, and I won't spoil you, but I will ask you later, and at the end of this talk, if it's a threatening topic or not or not. So they are coming for you, yeah. They are coming for your platform, even if they know who you are or who you or what do your business do. They are coming because everything is automated in this world, and we are against a massive industry. Cyber criminals is cyber infosec in the cyber criminal world is a massive industry, and we are going to get through that in this slide. So what are we going to see right now? We are going to have some very basic concepts, like what is the surface of attack and how the security risk scales up in equivalent to the surface of attack. There are another ways to calculate how the security risks are, but this will give you a sense of how hostile the internet has become in the last years. We are going to get some three of the most common threats. This most common, the most, I would say, oldest one, but still most effective ones. And other kind of attacks usually use these as basis to create more complex attack. So you will see that. We're also going to see what is INFOSEC industry business, some strategies and tools that we can do right now to leverage our defenses. We are going to share some conclusions about it. So this is me. I hope you will be interested on listen to me for a while. I'm software engineer and also keep studying because this is the area we choose to work. I'm DevOps culture preacher, beneficial AI enthusiast, open source guy. You will see some of the open source tool later this talk. I'm interested in physics and music, so I love cocoa and coffee. That actually is one of the reasons I get up in the morning always. You can find me on social networks. I'm working in Whitefront as a DevOps consultant. So what is the surface stack? The digital world is very abstract, and we often need to do some analogies to try to get into the concrete world. So this is going to be my attempt of giving you a concrete concept of what is the surface of attack. So let's imagine we have if we have a surface of attack, it's because there is a possible or there are possible attackers, right? And they are attackers because they have an interest, and this interest is usually value. In the older days, it was gold, and that's why we have castles around the treasure, so the king and so on. So this very basic concept, it is very simplistic for how digital works, but let's start from here. So if I will say to you, would you draw a castle? Would you design a castle in 1 minute to save something from the possible attackers? Maybe you will come to something like this. Seems high towers, so we can have some archers to take down some enemies, and this is because of high standing position. They will have some advantage, right? But this castle have some flaws that we can detect easily. First, the door. So the way we can end is there is nothing separating us from that door. Also, all the windows are possible ways of weighing to the castle, which is the thing we want to avoid. And also the material of the castle would even be part of this. But okay, it was only a minute. So if we probably give you a couple of hours in working teams, we might have something like this. And this, we are starting to throw some networking concepts and digital concepts here. So you have the critical asset. There is double guarded by water, which is basically some sort of isolation. Later, you have a couple of breaches from the first entry point and the second entry point. This will be the main surface of attack. But while it feels isolated and well guarded, each time technology get us to a better tool, or in this case, better tool to attack, you will start rendering some of these defenses obsolete. So let's say we have, I don't know, a deployable breach that can have easily be deployed for a couple of people. So, and you can have also some sort of drill and can get through these wooden walls very easily. So you pass to have only one surface attack, the outer scale, and later have a second wall. You get again this river, this moat won't be useful, and you know what I mean. So basically, this is a good approach, and we can start seeing how digital components become. But this is a very naive approach, even if we take this and get it into the cloud perspective. So if we give you enough time, or we give humanity enough time to see, and after probably a lot of attacks, a lot of successful attacks, it means failure at defending, we will come to something like this. It's not just a little river between the castle where the value is and where the possible attacker will come from. We also, each layer is higher than the previous one. You have not one but two bridges that are heavily warded, and to come in, to come out, you actually need to get through all of these different barriers. And of course, the value has to be big enough so the possible attacker will be interested into getting, right? But again, any new technology that can bypass or work around this kind of defenses will render them obsolete. So this is good until we have the aircraft. Aircraft came, and of course, none of this is useful. Unless, of course, you have a couple of dwarf and you create Minas Tirith, and that is a badass defense. Not even Nazgul could beat that. But leaving the joke aside, you can see in the Minas Tirith, which is just a virtual citadel castle, you see the same concepts. You see that there is one barrier and they have only one entrance, and each new layer of security is in a higher position. For security, we would say just have higher accesses, controls, or so on. Each time is difficult, and the value is probably just up there with the more difficult part to get. And the surfaces attack is just to check out the back. The mountain is taking basically just the whole back. There is reduced surface of attack because it's only the front that you can attack. So with this in mind, let's just do another, let's do a thought experiment in an abstract world. And let's say we are going to get to design a platform, or remember a platform we're working, or we are working currently. We can say an application or a set of application or services. And of course, this is a thought experiment, so we are going to have some freedom in some of the concepts we are going to introduce, but you can replace that with your real numbers. So what are the possibilities? What are the doors and the windows where the attacker can come in? It will be endpoints. If we are talking about HTTP or other kind of protocol, we have verbs. Verbs will have different combinations of the endpoint, how to access that endpoint. So it will render this endpoint in two different possibilities. So it will be two different points to come into your platform or application or service. We will have parameters, payload, design, and mail server. So payload will be the message, parameters, if the parameter for, if we're using URLs, the get parameters. Well, if we're using, for example, GraphQL, it will be the parameters inside of your queries, and even the different queries and different parameter combination will be different ways they can come in. So everything is about combinatory and probability. And so here's where I said, let's give it some freedom, because if we're using GraphQL, probably we won't have all the verbs. If we're using API like RESTful, we won't have only 4 endpoints. We will have much more endpoints. I have seen like APIs with a couple of hundred endpoints. And of course, not all endpoints will use the 4 verbs, but just for the sake of the thought experiment, let's say we reduce to only 4 endpoints. All of them use the 4 verbs. All of them use these parameters, and so on. So basically, we're reducing it to a 4 per each. If we use 4 per each, and each combination of them is a possibility to get into the platform, we are going to say that we are having 6 times 4 combination possible. However, this is only the possibilities of waiting, but or the windows of the doors. I can get in through a door using, like, knocking it down, using a master key, trying to tail somebody. So there are different ways I can break into, okay, check on the vulnerability for these possibilities. So just to give you an example, there is dozens of thousands of known vulnerabilities, and they are publicly. There are, for example, in the US, you will find the National Vulnerability Database. They have around 17 to 20,000 known vulnerabilities with their solution. There are a few hundred without resolution. And again, this is the known vulnerability. There are also public databases in the dark web or in these cyber criminals that have more vulnerabilities that we don't know. So the idea of this public is just to know what they can attack you, and you start defend yourself. But if we only take 10 possibilities for each of our possibility to get inside of our castle, our service, we are talking about that the maximum possibility is 40,000, so almost 50,000. So, and this is the maximum. Of course, you might not have some of them, and this is with a very naive defense, where just without any check. So this can be reduced, but just to give you an idea of how it's calculated, and probably is much more than only 40,000 for any given platform. And this is for any given moment. Today I can scan it, I can find these possibilities, and later check how much are vulnerable or don't. But if we are in a continuous development, tomorrow in the next release, we will have a different platform with different changes, different dependencies. So this combination will change every day. We'll see why this is critical. So let's check for the first threat. This is very basic threat, distributed denial of service. The goal for them is just to take down your service or to degrade your service to a point they are just getting their goal, either just take you down, or meanwhile they are taking you down, they are also getting in. And again, let's do an analogy, because this just is very easy to understand in the abstract world, but let's try to make it concrete. So in this case, let's imagine we have a tank for 10 liter capacity of water. We have a pipe which refill rate 1 liter per second, and we have a toilet. When you flush it, it will flush by 3 seconds, 3 liter per second. So it will waste, or it will spend 9 liters of water per second, while it gets refilled at 1 liter per second, the full tank. This has been designed this way because nobody expected that everybody will go flush the toilet at exactly the same time. Maybe that's the user market study say that. However, this leaves open the door for somebody that has bad intentions and can just flush it one and over again and it will basically deplete the tank a very quick rate, and we spend very low resources. So only one person can do that. However, in the digital world, we can automate these kind of things. And in the digital world, of course, we don't plan or design for 4 users. We design for thousands of users, right, and thousands of connections. However, automate thousands of connections is very easy and it's very cheap in the world. We will see in the next thread how. So if I can automate for some reason, I don't know, just take a string and flush the 4 toilets at the same time, even in the first flush, the 4 toilets will be affected at the 3rd second. They won't be successfully refilled. They won't be able to flush completely, right? So this can be an analogy of we are going to serve to a user a slow connection, or we are going not to be able to process that connection. That could be a transaction, that could be just a conversion. You can imagine whatever action you want in that direction. So what I said in the beginning, only one person using just its own resources can just go to a point where he can find a breaking point. How much he has to do it to get to that breaking point. That's something very easy to do with a small bot, even with your computer and your home connection. So what is the actual threat out there? So this year, we got a new record in the DDoS attack. Basically, Amazon was attacked with a 2 terabyte per second attack of DDoS. This is a lot. And just to give you an example or a sense of your idea, basically one request per user for, I don't know, downloading and their registry will be a couple of kilobytes, which is like 3 or 4 degrees less than a terabyte. But that's about infrastructure. So if you have one virtual machine, let's say it's in the range of a million to good virtual machine, and you have open to the world, and you have a public IP there, probably you will be from 500 megabytes to 1 gigabyte, 2 gigabytes per second, just to physically be able to ingest that information. Your services behind of that probably will be able to ingest with a lesser rate. But let's take the upper limit. So it's 1 gigabyte. If you invest in a very, very costful virtual machine out there, it will get up to 25 gigabytes per second. But usually that is used for internal communication, for data processing, and so on. So we have, of course, load balancers. Load balancers will charge you for this kind of bandwidth. What we have commonly outside will scale up enough to 20 to 30 gigabits per second. If you pay enough, which is quite expensive, you can get up to 100 gigabits. There is no much literature about this. I guess that nobody's wanted to publish how much their load balancer, or when they will break, or the breakpoint there is reasonable. But right now we have 2 terabytes. I mean, there are botnets and there are cyber criminals that can direct to one platform 2 terabytes per second. So just to give you a sense, which is the capacity that they have out there. So let's say, let's talk about this botnet. This is something I have just mentioned right now. This botnet is a network of bots. Blah. There is nothing new there. But the newer version of botnets, they are self-replicable, so they work like a virus. And I won't extend that because I think today we will all know how a virus works. So after they infect one or a couple of nodes, they will try to replicate themselves, right? But they also not only do that, they can scan their network and see, hey, I found another vulnerable node, and this is a protected node, I don't care. So in this case scenario, it's a 50-50%. It can be lower or less, it doesn't matter, you will see why. So they also ephemerals. After they infect a node and they move to the next one, they can delete everything they have done in the first node. So the ephemerality is also very hard to track. Also, there is a new, or there has been this decade, what they call CNC, basically an outer node that is just dedicated to send commands and try to coordinate these attacks. And this coordination is usually automated and using edge technology, like AI. We will see later about that. So they can say at some point, hey, attack. And this can be infect a new node, or this can say, hey, just send a request connection to this particular site or platform. So from remotely, you can just say to the world, your botnet, hey, attack this particular endpoint, and they will randomly or at the same time do it. So that's how you get massive DDoS that we have discussed. Of course, if you check this on the costful perspective, or how the cost perspective, sending this kind of command is very cheap. And after you get inside of one node, it's very cheap to self-replicate and to increase this even exponentially. So security risk grows exponentially, but also the capacity of the cyber criminals to attack you grows exponentially as well. And something that we can say, well, what is a node? Basically, a node can be your smartwatch, it can be your smartwatch machine, can be your computer, can be your phone, it can be an older phone which is connected for some reason, an IP camera. All of them more today with EOT, this has just exploded, and EOT is also growing exponentially. So each of these devices is also a possible node to infect, connect, and to own. And more, even more, I say, even more dangerous is that they can connect back and they can send information back, like, I don't know, your browser history, or they can say what kind of files you have in that node. If it's a camera, it can take camera processor information, send it back. Maybe this can help the cybercriminal later for our next threat. Just to give you an example before we're going to next threat, the Spam House has identified to 2019 more than 15,000 bots with the CC bots. I mean, those red big circles we have there, the coordinators, more than 15,000. So if you check, if you think that each of them can manage from 100 or 1,000 of bots, you can start to see how this grows also exponentially. So let's talk about another one. This is ransomware. So basically with ransomware is some sort of ninja kidnapping style. They don't need to do it right away like DDoS. They need to all attack at the same time so they can break your part or your platform. With ransomware, they can go layer by layer, 1 month, 1 day, another day, and wait. So maybe you have your whole platform secure, and they just are knocking the door until they got into the first barrier because you are doing some changes, and stop there. And later we'll scan through the time, waiting for the dependency or waiting for the vulnerability. I got for the second layer, and so they can start coming. Actually, one of their laws is go low and go slow. So after they got into your fullest protected placeholder, like castle, house, server, whatever, they can take the value, but instead of taking out like would happen in the real world, they can just translate it into Armanto, to Latin, to Japanese, and you can do nothing later with your value. You can either learn Japanese and try to translate it back, and it will maybe take you 6 months and 1 year for any business. That will just be a deal breaker. Or you can just pay them, and you can just pay them to translate it back. And of course, I use Japanese to make it real, but basically they will use cryptography techniques that it will take you a couple of thousand years to translate it back, if possible. So after all the whole connection, all the recollection of information they have done through their path, and also another kind of information collection for your social networking, or for those, in financial report they found in your computer or in your systems, they will know you better about how much they can charge you. And this information is fed into a AI model, just logistic regression model or whatever, and just they are trying to predict how much you will be able to pay. I mean, how much you are going to accept to pay for that. So this model are just basically using this technique, which is very similar to what kind of ad will you click. It's exactly the same technology, but basing on how much will you pay. So I will ask you that range of price to give you back the information. For individuals, they has been detected that go from $100 to $3,000, but for organization it comes from $300,000 to more than $1 million. Just to give you an idea, in the last couple of years, they were able to trace back to a single Bitcoin wallet more than $200 million using one kind of ransomware attack. So let's talk about the potential growth of INFOSEC. From the 2011 to 2019, the INFOSEC legal, the good guys, so they're working for creating tools and services that protect from this, has grown, and their profit not the cost, the profit from $55 billion to $124 billion. That is a good amount of growth. For this year, the US commerce penetration grew from 16% to 27% in only 8 weeks. So just a couple of months, it got more than 50% of growth. So I'm talking about US e-commerce because it's very sensitive for networking payments like credit cards and so on. But this give us also an index of how all the metaverse, the digital metaverse has grown. However, for 2020, we don't have yet reliable information because everything is very new, but everything seems to be like what we have grown in the last 10 years. It will be grown or outgrow this year. From 2015 to 2019, internet usage went from 3 billion users to 4 billion users. I guess this year we will hit 5 billion users or nearby. So this is only some information about the legal stuff, like where is our side, not the cyber criminals, but also how much are we paying as a collective for security, how all the surface of attack, if you think of digital world growing, just how is it growing, which rate, and how many users, which are possible targets, also growing. So it is a very optimistic, unfortunately for them, for the cyber criminals, it's a good year for them, let's say. So let's do the while we cannot have their information on how much they are earning because they probably don't do accountability or public accountability, we can have an idea of how much that industry worth currently. So if we take, for example, if you will buy an alarm system for your car or for your home, your home just worth $100K, you probably won't buy an alarm system that costs $100K as well, because the ratio has to be some degrees less. So let's say for your car you have $20,000, you probably will buy for $2,000 alarm system or $100 alarm system. I don't know. It will depend, of course, on a lot of things. But the car is something that you can replace. In the digital world, there are some things that you cannot replace. So it is the alarm system, the security system you will be able to pay more for that, or you will be will want to pay more for that. But let's do a simple math here. So we won't have particular numbers, but we can see how this works. So if 2019, the public, the legal, the good guys were able to profit $124 billion, and we use a ratio of 5 to 10, in 2019, that industry worth $1 trillion. Just multiply for 5 to 10, and you will get it to $1 trillion. And this year, we are talking about, we have a massive amount of growth in all the areas. Probably it will be more than $1 trillion for this year. And this is a big incentive for another cyber criminals to keep growing and keep attracting more people that will become cyber criminals as well. So everything is based on massive attacks. So even if you have your platform, a small platform there, it will be a scam. So how this profit, and I will steal from you a couple of more minutes, and we're about to end. Both sides use this math, as you can see. Cybercriminal do DDOS as a service. I mean, you can go in the dark web and say, hey, I want this site to go down, and it could cost you around $700 to $800 a month. So it's not much. Probably the people doing that platform is spending thousands of dollars to make that a reality. So cloud providers or virtual machine providers, as an infrastructure provider, they started to see DDoS attack as a business as well. So they offer DDoS attack protection. So for the ransomware as a business, you will see that there are a couple of models there, and we'll quickly do that. But basically, you can pay them $60 and point to a target. If they are successful, they will give you the 50% or give you the 70% of the successful attack, or otherwise they will give you $60 and a USB drive, and you will be the human driver of the virus or the whatever rootkit, and so on. There are a lot of models, and there is very small people working the both sides. But the message here is there are techniques and strategies to work, and this is the main message for this talk. We have INFOSEC practices, and these are things that you can do, and you can do it now. embed your security in your design process. There are something like Mozilla Rapid Risk Assessment, which can help you say, how much do I need to invest? Because again, it's a ratio between the value you have behind your platform and the interest that the cybercriminal may have. So it's not that they will give you a 2 terabytes attack for your small, I don't know, GIF, cat GIF platform, because they might not have that profit from that. Try to use not allow by default in any security access. In this case, less, I mean less. I mean, if you can have less endpoints or less surface exposed, you will be less probable to be successfully attacked. There are other practices like DevSecOps. It basically embed in your software development lifecycle some best practices, like from designing, coding, testing, deploying, have policies that will get you to a better place, like security scanning, static scanning, or dynamic scanning, and so on. Also, let's also check about this shared responsibilities. All the team is working with the goal of being secure, you will have a more secure platform. For tool and tactics, we have a couple of open source tools, which are basically standard in INFOSEC security business, is OWASP Sweep and SonarQube. Open source, they have their premium payment ones, but with the OWASP suite and the SonarQube static analysis, you will have a very good baseline of security for your application. Of course, you will be constantly tracked and scanned. You can offer to the community, hey, if you find a bug or a vulnerability, I will give you some money back or some recommendation, or I don't know, whatever kind of incentive, so they can report to you and not just exploit it. There is a lot of good people out there that they do this for the living. So we are getting to an end. If you want to know more about security, the OWASP Security Specialist has a great podcast. They have a plethora of podcasts about security. There is also a great talk about top 10 best security practices in Azure. The first part is about, they go deeper in this kind of attacks I talked today. And also Confession for a Cyber Spy Hunter. There is a great TEDx talk about it. This will be recorded and you can ask me later for the links I can send you. So this has been the talk. Thank you very much for listening. And if you have any question, you can just throw it in the chat. I will also leave a participant, if you want to unmute and ask through audio, you can also do that.
Thanks a lot, Rafael. Great talk. Very informative. I mean, thinking on the 2 terabytes per second denial of service, that is like a lot of requests going to a single, that only is done with a lot of money, right? There is a lot of people being paid to build these attacks and put them together, right?
Yeah, that they're probably for doing that, it will be a mix of things, right? Maybe people who get their funds infected and they don't know they are part of the botnet, and a lot of people who are being paid and are part of cyber criminal organizations. So I would think of, to get that kind of massive attack, you will need a mix of these both worlds. They often, I say that because they often try not to attack directly, because in nowadays technology is easy to trace back when you attack directly from your computer, for example. So these cyber criminals who knows how to do this in both ways try to use different kind of proxying. So the best proxying they can have is to infect somebody who doesn't know that. So if somebody traces back to him, to her, to that person won't be able to say, hey, I didn't know about this.
incredible how much this has evolved. One comment that I put there, I don't know if you knew, but the Dirección of Migraciones received a ransomware attack a couple of weeks ago. Allegedly, they didn't pay anything because it wasn't very sensitive information what they got encrypted, but who knows what else they did while getting access to those servers.
Yeah, there is there are a couple of things I checked in these videos I sent. I shared. Basically, first, not everybody that pays for a ransomware attack actually reports it. So what we see of $124 billion basically is biased for the people that didn't report the attack, just pay $100 or so on, and we never knew about it. Well, the other thing is that unfortunately most of the companies in the world, they think this is an embarrassment, that okay, we didn't do the things right, so they try to keep it low for their branding purposes or for the trust in their customers. So as you said, we don't know if they pay or don't, but also these kind of attacks that may be used as a diversion. Meanwhile, you have all your cybersecurity resources pointing to how to assess if we need to pay or don't, how to trace back where the ransomware come from. They might be doing something else.
They are deleting someone who crossed the border from the records, right? Or something like that.
That
putting
could
someone
be,
there.
That could be, exactly. And that's even greater risk, actually.
Yeah.
So thank you all for listening. If you are interested in getting deeper on any of the concepts or any of the talks, just give us a Fabrizio or me a ping, and we might have we might get another talk about some deeper concepts.
That would be great indeed. Yeah.
Thank you.
Thanks a lot, Rafael.